All right, here we're going to be classifying triangles using the Pythagorean theorem. And we've already kind of done this a little bit when you look at Pythagorean triples and you look at three measurements and decide if the things could be a right triangle. We use the Pythagorean theorem to figure that out. But now we can take it a little bit of a step further, and we kind of think of it this way. So if the Pythagorean theorem works, all right, this is the one we already know. If the Pythagorean theorem works, we have a right triangle, all right? But when we think about the relationship between the opposite side and the opposite angle, if I use the Pythagorean theorem and it doesn't work, but the hypotenuse side is too small, okay? So when I did a squared plus b squared equals c squared, the c squared comes up short, it's too small. It means the angle across from that is also too small, which means instead of a 90-degree angle, I have something that's less than a 90-degree angle, which means I have an acute triangle. All right. Likewise, if I use the Pythagorean theorem and the c squared value, the hypotenuse value is too large, it means that the hypotenuse itself is too large. All right. And if the hypotenuse itself is too large, then the angle across from that is also too large to be a right triangle, meaning that it's bigger than a right angle. So it's an obtuse angle, which makes it an obtuse triangle. All right. And so here's kind of what this looks like. If I show you a couple triangles here, using the same measurements for the legs, but the first one's going to be a right triangle, and the next one I'm going to change the length of the hypotenuse. You can see how that changes the angles. Okay, so here's what this looks like. If I look at this guy, this first one is a right triangle. If you were to plug it into the Pythagorean theorem, you're going to get values that work. Watch this: a squared plus b squared equals c squared. And that's a 36 plus 64, which equals a 100. And so I get 100 equals 100. This is a right triangle. And so this right here is a right angle. But what happens is if I were to take the hypotenuse and make the hypotenuse smaller, like I did here, what happens is the angle across from that also gets smaller. So now instead of being a right angle, that is now an acute angle, making this an acute triangle. All right? And here's the result when we plug it into the Pythagorean theorem. Ready? A squared plus b squared equals c squared. And so when we looked at the first one, we got the exact same value, but here, the side with the hypotenuse comes up a little bit short. Notice the side with the hypotenuse is only 81, and it's supposed to be 100. It's too small, which means the hypotenuse is too small. And so when the hypotenuse is too small, the angle across from it is too small, meaning that I have an acute angle instead of a right angle. And that makes this thing an acute triangle. And so not only can we say whether or not it's a right triangle or not, but we can actually classify what kind of triangle it is. So this one was a right triangle. This one is an acute triangle. And you can already look at the last one and realize that it's obtuse, but here's why. Once again, if you compare it to the first one, when you look at this guy over here, I had a 10 for the hypotenuse. If I make that side a little bit longer, if I make it at 11, what it does is it makes the angle across from that a little bit bigger. So instead of being 90 degrees, it's going to be something bigger than 90 degrees. It's going to be obtuse. And here's what it looks like, once again, when we plug it into the Pythagorean theorem. A squared plus b squared equals c squared. And what happens here, I get 36 plus the 64 again. Notice I haven't changed that. I'm just changing the hypotenuse side to kind of make that side a little bit longer, which changes the angle. And so what happens here is the hypotenuse side is too big this time, all right? And that's because I made the hypotenuse bigger. If the hypotenuse size is too big, it means the angle across from it is too big, meaning that I have, instead of a right angle, I have an obtuse angle, making this an obtuse triangle. Okay? But that's the effect that this has. So not only can we decide if it's a right triangle, but we can actually classify the triangle as a right triangle, an acute triangle, or an obtuse triangle based on that hypotenuse side. Okay? If it equals that hypotenuse side, then it's right. But if the hypotenuse side is too small, it's acute. If the hypotenuse side is too big, it's obtuse.